Hey everybody, we are in lesson 7.5 of the Tennessee Revealed Geometry on rhombi and squares. Okay, so we're still in the parallelogram family, which means opposite sides are parallel, opposite sides are equal, opposite angles are equal, diagonals bisect each other. Oh goodness, what else? Well, something specific about the rhombus and the square is that not only are your opposite angles equal, but your interior angles, where like the diagonals bisect each other, they're all 90 degrees. So inside angles on a rhombus are 90, and same thing on a square. That doesn't happen on a rectangle or parallelogram, by the way. All right, so let's get into it. So a rhombus is a parallelogram with 4 congruent sides. So is a square, by the way. So this rhombus, all 4 sides are equal. All right. Diagonals are perpendicular. Okay, just said that. That means that when the diagonals intersect each other, the 4 angles on the inside where they intersect are 90 degrees. All right, and diagonals bisect opposite angles. So when the diagonals are drawn through the vertices, the angles will be cut in half. Same thing on a square, by the way, except they're all going to be 45 degrees automatically. I'm sure we'll get into that. Example number 1. So I'm on your workbook, page 437, and we are on example number 1 on page 437 at the bottom of the page. And let's see what we got here. It says, use the definition of a rhombus. So they're saying this is a rhombus. LM, which is one of the sides of the rhombus, and KN, which is one of the sides of the rhombus. Well, they're automatically going to be equal to each other, and they want us to find X. So I am going to set those equal to each other. The 4 sides of a rhombus are the same. So that LM is going to be equal to KN. So I'm sure that's what they're going to want me to do. All right, KN. And so that will be equal to Kn. And that means it's equal to X plus 15. Oh, come on. You don't need this. Plus 15. Once again, I do not like that they want us to solve this by not showing any steps. So for my visual people, I'm definitely going to show my steps. Okay, well, the opposite of adding X to subtract to the other side. So minus X minus X. 2X minus X leaves an X. Minus 9 equals 15. The opposite of subtracting 9 is to add 9 to the 15. Oops, sorry about that. And 15 plus 9 is going to be 24. It looks like X is 24. And I guess that's all they want me to do. I'm going to turn the page. Yep, going to a check. All right, so we got a quadrilateral, WXYZ. It's a rhombus. AZ is a bisected part of the diagonal. XZ is the entire diagonal. XZ has been bisected, which means AZ and XA are the same. Okay, so this right here from A to Z is 14. Y to Z is 22. WYZ, this angle is 35, which means the angle is beside it is 35 because angle Y has been bisected. And we got to find each measure. Okay, so let's see what we got first. I need to find XZ, which is the entire diagonal. Okay, so listen, if AZ is 14, then AX is 14. 14 plus 14 is 28 for the entire XZ. 28. Moving on. All right, XYZ, XYZ. X, Y, Z. They want us to add these two little parts together to get the entire angle Y. Well, if WYZ is 35, then its counterpart is 35. 35 plus 35 is 70 degrees. So X, Y, Z, 70. All right, WXZ. WXZ. They want this angle right there. Okay, well, there's several different ways you can do this. If I know that this entire angle is 70, and these are supplementary, big angle X and big angle Y, I can do 180 minus 70 is 110, and then divide it by 2 to find out what each one of these is, which is going to get you the right answer. So 110 divided by 2, that would be 55 and 55. That's one way to do it. Okay, not the only way. Okay, let's talk about this for a second. If this angle that they gave us in the directions WYZ is 35, this angle right here is 35. Its alternate interior angle up there is 35. Now, because this is a rhombus, this angle A right here is 90. 35, 90, and what number would make 180 for the sum of the angles of a triangle? So add up your 90 and your 35 together, subtract that from 180, and you will get the same answer I got, 55. So there's another way to work it if that's what you want to do. Doesn't really matter which way you work it, you get the same answer regardless. Example number 2. All right, you guys, I'm on page 438 in the middle of the page on example number 2 of your workbook. All right, it says use the diagonals of a rhombus. We need to know the diagonals bisect each other in a rhombus. So let's talk about this. They intersect at P. All right, angle LMN is 75. Now, if you want to find each individual one, remember take 75 and divide by 2. All right, we got to find KNP. KNP. Okay, well, it's the same type problem, I suppose. Looks like they did the 180 thing. All right, well, that's fine. There's more than one way. So you could have done 180 minus 75 to get the big angle in, KNP. But then you would have had to have divided it by 2 to get the individual ones, which, is more than fine. Or you can realize, okay, look, 75 divided by 2 will give you 37.5, 37.5, which means both of these are also 37.5. Given that this is a rhombus, angle P, this angle right here is 90 degrees, and 3 angles of triangle KPN equal 180. So you take 180, subtract the 90, and subtract the 37.5. Grab a calculator, it'd be 52.5. 52.5 degrees. All right. Looks like that's all they're doing for example number 2. So let's mosey on down to the next example number 3. I'm at the bottom of your page. Again, still on page 438 of your workbook. All right, so we got a square. Okay, so this is what you need to know about a square. It is both a rectangle and a rhombus. It has what I explain to my students, attributes of both of its mother and father. So the sides, all 4 are equal, just like the rhombus. The angles, big angle E, big angle F, G, and H are 90 degrees like the rectangle. The inside angles are 90 degrees like the rhombus. So this angle J is 90, 90, 90, 90. Diagonals bisect each other like the rhombus, but they're actually equal to each other like the rectangle. So EJ, FJ, GJ, HJ are all the same. And the angles bisect each other by the diagonal, which means these little bitty angles are 45, 45, 45, 45, 45, 45, 45, and 45. All right, let's see what we got to do here. FJ is 19. Okay, so F to J is 19, which means E to J is 19, H to J is 19, and G to J is 19. And they want me to find FH. FH is the entire diagonal. Okay, well, listen, if F to J is 19 and H to J is 19, you are going to just add them together. Add them together because they are equal to each other. So 19 plus 19. Oh, my bad. That right there they wanted FH. My apologies. So 19 plus 19, or just 19 times 2, if that's your preference, is 38. All right, distance from F to H is 38. All right, we got to check here. Rhombus. Okay, so PQ is 4x plus 3. QR is 41. Well, these are sides of the rhombus. That means they're equal to each other. So you would set those equal to each other. All right, what else we got here? PQT, PQT is this angle is 2x plus 4y. All right, we got to find y for the rhombus to be a square. Okay, let's see what's going on here. This is interesting. So first thing I'm going to do is I'm going to set these two equal to each other to find x. Because they are sides of the rhombus, they are the same measure. This is going to get me x. I'm then going to take that x and substitute 4x right there for PQT, which is 45 degrees, because if it's a square, all these little angles are the same, because if big angle Q, PQR, is 90 and it's been bisected, they're 45 degrees. So several things going on here. All right, first let's find x. That means I am putting 4x plus 3 equal to the 41. All right, the opposite of adding 3 is to subtract 3 to the other side. Well, 41 minus 3 is going to be equal to 38. The opposite of multiplying by 4 is to divide by 4. So 38 divided by 4, 9.5. This is going to be our x value. So I'm going to replace x right there. So now it's 2 times 9.4 plus 4y equals 45 degrees. So if you're a teacher, have your students watch out for this little degree symbol right here. My students do not recognize 90, 180, things like that as an angle. They will try to make these things over here, which are sides, 90 and 180. And you have to watch out for the degree sign. So a lot of students will ask, well, what at 180? Well, because these are not angles. This is an angle, and it's in fact a 45-degree angle, because on a square, the 90-degree angle has been cut in half. So I'm going to set it equal to 45. Okay, so 2 times 9. I said, I made a mistake, you guys. It should actually be 9.5. I typed it in wrong. My apologies. So 2 times 9.5 is 19. Bring down 4y equals 45. All right, I'm going to subtract 19 to the other side so I can get my numbers that do not have letters combined together. So I'm going to subtract 19 to the other side. 45 minus 19 is going to be 26. And the opposite of multiplying by 4 is to divide by 4. So 26 divided by 4 is 6.5. If I can type it in correctly this time. So y is 6.5. All right. All right, fantastic, you guys. That is 438, the check. And we're going to move on to the next page, page 439. in your workbook. All right, so we got a test for the rhombus and square. The diagonals are perpendicular, then it's a rhombus. Oh, well, the diagonals can be a square. Diagonals of parallelogram bisect a pair of opposite angles, then it's a rhombus. Same thing for the square. Two consecutive sides, parallelogram congruent, then it's a rhombus. Same thing for the square. If a quadrilateral is both a rectangle and a rhombus, then it's a square. Absolutely true, because it has attributes of both. All right, I've talked about that. All right, example number 4. Write a paragraph proof. Okay, well, I'm skipping that because we are lucky enough in Tennessee that was taken out of the curriculum this year. They just didn't update their books. All right, example 5. All right, so we got a design here. Ananya is designing a sweater using an argyle pattern. All 4 sides of the quadrilateral ABCD are 2 inches long, so 2, 2, 2, 2. So it appears to be either a rhombus or a square. How can Ananya be sure that the argyle pattern is a square? Well, just because these 4 sides are equal doesn't mean it's a square. It could be a rhombus. So I guess the first thing I need to do is figure out if these diagonals are equal to each other. Because in a rhombus, they would bisect each other, but they would not necessarily be all 4 congruent. All right, square is a parallelogram. Square works to rhombus. Okay. Let's see. I have to turn to the next page in the workbook to figure this one out. Okay, here we go. Okay, because both pairs of opposite sides are congruent, ABCD is a rhombus by their definition, because the 4 sides of ABCD are congruent, and it's a rhombus, so the four sides, I suppose. All right. The diagonals of a parallelogram are congruent, then the parallelogram is a square. Okay, I just said that. I love it. I'm just getting ahead of myself. So if Ananya measures the length of each diagonal and finds they are equal, then the ABCD is a square. Okay, well, I just said all that because that really is the difference between a rhombus and a square. All right, are they going to have us do that? No, we're just proving. Weird. All right, by the way, that would be the Pythagorean theorem. Pythagorean theorem. Because this is a 90-degree angle, 2 squared plus 2 squared equals c squared. And up here, 2 squared plus 2 squared equals c squared. So that's a good way to see if they're equal to each other, if you get the same answer on the Pythagorean theorem. All right, example number 6. And it looks like this is our last example. I'm on the bottom of page 440 of your workbook. You know what? This, I think, is going to be a good problem for GeoGebra. Let's see what we got here. Determine whether ABCD of vertices is a rhombus, rectangle, square, or none. List all that apply. Aha. Yes, I am most definitely using GeoGebra. And I like doing this, you guys. Changing it up. Give my students something else to do. And this is a great hands-on activity for your hands-on learners. There's nothing wrong with that. So I need a -3, 2. I need a -2, 6. I need a 2, 7. So I need to move this down a little bit so I can get to a 2, 7. I need a 1, 3. All right, well, here we go. Go to Polygon. -3, 2 is my A. -2, 6 is my B. 2, 7 is my C. And 1, 3 is my D. Don't forget to go back to A. Well, it's definitely not a square because this angle right here is most definitely obtuse. And angle A is acute. This is not a square. And since it's not a square, it's not a rectangle because the outside angles are also 90 degrees on a rectangle. But I do see all 4 sides are equal to each other. Side A, little a I'm talking about, is 4.12. So is B, C, and D. Well, that means it's not a parallelogram. because on a parallelogram, opposite sides would be equal, but not necessarily congruent. This is a rhombus. Most definitely a rhombus. All right, so going back to this. Well, there it is. It says it is anyway. All right. So it looks like they do the slopes, the diagonals. They are 4 1/4 for AB and AD. So that means they're 1 and negative with opposite reciprocals. Okay, so the diagonals is, product is -1. They are opposite reciprocals. All right, so that means it's a rhombus. Well, and I hope I proved that to you guys. And I love hands-on activities for my students. Sometimes it just sinks in better for the students. All right, the practice is up for you guys. Page 441, that is all you. All right, listen, you guys, if you have any questions, ask your teacher. Ask me. I'd be happy to help. You guys have a great day. All right, bye.